Hi everyone, welcome to Caltex Academy. Today on our board, we have two interesting questions on term substitution. So when we see carefully, we realize that the denominators of these two integrals are quadratic in nature. So if you're interested to see how these questions are tackled, you're most welcome and come closer. Let's dive into the video. So let's start by copying the denominator of the first question here, somewhere here, and we use completing squares to factor it out. So we have x squared plus 6x plus 10 equals 0. We just need to pretend that we are solving a quadratic equation using completing the square method. Now, since our coefficient of the leading term is already 1, then we have to take the constant term to the right hand side of this equation and returns to -10. So this gap, we can fill it by getting half of this coefficient of x, which is 3, and we square this half of the x coefficient here, and we add this to also the right hand side. So we have that. Now we can expand this and we have x squared plus 6x plus 9 equals -10 plus 9. So we can also simplify the right hand side. That goes to 1. And here we need to complete the squares by getting one of these x. Then we get the half of this coefficient, which is 3, together with its sign, and we have plus 3. Then we close this bracket and we get one of these squares, placing it here, such that if you expand, you can get exactly back this. And this one came from there. Now, after reaching to this stage, you realize that we have two terms in either side, so we need to bring them to one side. So let's just take this to the other side here, and we have our x plus 3 square. Now when this negative crosses the equal sign, it changes to positive 1 equals to 0. So remember, this 0 was not part of our working. We just brought it here to make our computation here easy, so we can just ignore, and we're only interested in this term here, that is x plus 3 squared plus 1. And let's use this to replace our denominator in question number 1. Now we can start our solution by taking question 1, and for now I'm just only naming it like this, and I'm writing the new format of our question, which is the integral of. So let's try to be a little organized by having this division sign drawn here. Let's have here x, and from the denominator we now copy this in place of x squared plus 6x plus 10. So let me swap it starting with 1. So we have here 1 plus into x plus 3 square, and we're integrating with respect to x. So having written this, the next thing here is to take this term inside the square and we equate it to tan, and this is where tan substitution comes in. So let's have our x plus 3 equals tan theta. Let's differentiate the left hand side with respect to theta, and we have here the x. So the right hand side is secant square theta d theta, because if you differentiate constant, it goes to 0. So the derivative of x is 1. 1 times dx is just dx. So let's move on and make substitution, changing this variable from x to theta. Now again, we can use our ruler here, and we have our x is tan theta. So this tan theta will be joined by 3. So to make x the subject alone from here, maybe let me move up here and say our x is equivalent to tan theta minus 3. So that we only have x isolated. So here we also have minus 3. And from the denominator, instead of writing x plus 3, we're replacing it with tan theta. And since it is also squared, we can square tan square theta. Instead of writing the x, we're replacing with our derivative here, that is secant square theta d theta. The denominator is the same as what we have here. We can simply go ahead and cancel. But if you also need one more step, let me do it for you here. And we have denominator as tan theta minus 3. So from the denominator, we have secant square theta times secant square theta d theta, that came from the derivative of tan theta. And from here, we can now move on and cross the denominator secant square theta with this one. Now we have to rewrite the remaining terms, and here we have this is equivalent to the integral of, we have tan theta minus 3 d theta. So from here, this is now direct, and we can go ahead and integrate this. So if you know how to integrate this using the long form, go ahead and do that. For now, I'm using short form. Otherwise, the long form is, we know that tan theta is the same as sine over cosine. And I've done it in one of my videos. The link is in the description of this video here. You can go ahead and also watch that. So for now, to save time, the integral of tan theta is simply ln, let's have this notation, absolute value of cosine theta, and you can also close it here. Now we have two terms there. The first one is this, and the second one is 3. For constant is just we attach the variable in which we are integrating with. So we have here 3 theta plus our constant of integration. Now at this moment, we need cos theta, and also we need theta. And from our substitution above here, remember we had tan theta is given by x plus 3. So we can do it somewhere here and say, okay, and maybe we use a different color, white. Tan of theta is given by x plus 3. Now to get our theta, we can get tan inverse of x plus 3, and that takes care of what we have here. Now let's take a look at also cos theta. How do you get cos theta? Again, we can draw a right angle triangle. Let's draw a right angle triangle here. Again, from this right angle triangle, we also know that from tan theta, which is given by x plus 3, we can give the whole of this over 1. Also, we know that from the definition of tan of any angle, say theta, is given by opposite over adjacent. So reorganizing our opposite from the triangle here, so this is x plus 3 as our opposite to this angle. The adjacent is this side here, which is 1, and we need hypotenuse because we have cos here, so the hypotenuse is the square of 1, which is 1, and we add it to the square of this term, that is x plus 3, and this is from Pythagoras theorem, so that is our hypotenuse. Now we can go ahead and write relationship for cosine. Now we say cosine of any angle theta is given by adjacent over hypotenuse. So from here, our adjacent is 1, meaning cosine of that angle theta is given by 1 over hypotenuse. And now hypotenuse is under root of 1 plus x plus 3 square. So from here, we can move on to our solution and replace these parameters by this. So let's continue, and since we have a fraction somewhere, we can make this a little bit longer to accommodate our fraction here. And let's have 1 over, again we have our 1 plus x plus 3 square. Let's extend this a little bit, and then we close that. Let's move to this term here, and we also have minus 3. So theta is what we had earlier on here, that is tan inverse of x plus 3. So let's insert here, and we say tan inverse of x plus 3 plus our constant of integration, and that is the solution for part A of this question here. So if you have got some good value from this video, consider subscribing to the channel, like this video, and share with friends. So with all this said, let's look at how our question number 2 looks like, and we also go ahead and solve it. So for question number B, it says we have to get an integral of 1 over x squared plus 2x plus 10 raised to power 3 over 2. Now let's move on and rewrite this down here. So our question is, we need to get an integral of so we have bracket, denominator is 1, x squared plus 2x plus 10 raised to power 3 over 2 with respect to x. Now here we can go on and do the same thing as before, where we can first of all take the denominator and we solve it out using completing the squares method, where we have x squared plus 2x plus 10 equals 0. This time I will be moving a little bit faster because it's the same thing we have just done in our question A. So we have negative 10. So we have here 1. Also we're adding 1 here. And we have x squared plus 2x plus 1 should be equivalent to negative 9. Completing our square here, we have x plus 1 square. Now we can bring this together also. So we have here positive 9 because it was negative 9 and we have brought it back to the right hand side. So taking this and we make substitution to our question here, this will be equivalent to the integral of, now we can keep our work still organized here by drawing this division sign and maintaining 1 up there. So we can go on and we create a bracket here. I think I'm comfortable with this type of brackets. So instead of writing here, let us write here, and also I'm starting with 9. So we have here 9 plus x plus 1, and we square it. Let's also close the same bracket here. And the next step is to factor out 9 so that we obtain 1. So we go ahead and do that here, still maintaining our numerator as 1. And this is with respect to x. So when we pull out 9, then we open up this bracket, we shall have here 1 plus, here I need to create another special bracket inside here, and what we're going to fill in is the inside part of this bracket, that is x plus 1 over, so let me bring 3 here and the square outside here, closing up this bracket. So let me explain a little bit. So what I've just done here is like dividing the whole of this expression by 9, such that if you are opening up this bracket, you multiply 9 by 1 to get back 9, then 9 by the other 9 we had here, that is going to cancel, and you get back this if you open up this bracket here. And secondly, here is we need to get out a common exponent, that is 2, such that if you square the first number here, that is the numerator, we get back that. So if you also square back this 3, we get back 9, which we have given as a denominator here for opening up the bracket to obtain exactly the same value. Now with all this said, let's move to the next step, and we know already that the next step is to let this guy here to be equals to tan theta. So let's make it somewhere here. Now we have x plus 1 over 3 equals tan theta. You can choose to take any other parameters like theta, beta, alpha, any of them works. So for me, I'm used to theta, and let's continue with theta. Now let's take out this denominator by multiplying through by 3. So we have here x plus 1 equals 3 tan theta. After that, we have to differentiate the left hand side with respect to x, then the right hand side with respect to theta. And the derivative of tan theta is secant square theta d theta. So let us move on to the next step here to change our variable from x to theta by replacing any x with our new term theta. So we can do that by having this line drawn, and we have 1 from the numerator. So here we can keep our 9 somewhere here, and inside here we have still our 1 plus, so instead of writing x plus 1 over 3, we have already said that is the same as tan theta. I'm not placing it here. Since also because it is a square term, we can also square our tan here. And we close up that bracket, and the x can be written the same as 3 secant theta that. So before you proceed on, we have just kept one thing out here. Let's get back and see the question properly. It is having a power here, 3 over 2. So let's include this from our working here. Starting from here, we can say we have here 3 over 2. Now here, we know that from indices, if you have 3 over 2, we can split it into 2, just like 3 over 2 can be written the same as 1/2 times 3. So this 1/2 as a power is referring to us also square root. So meaning we can place this number under square root. For now, let me maintain also the same power here, and in this stage we can go on and include square root sign here. So we have that as a square root like that. So the whole of this is raised power 3, because as I mentioned here, we have 1/2 as a power, which is the same as our root sign here, and then the 3, which is this one, is multiplying the whole of this together. And also we need to create more space here by erasing this part a little bit. We have there our integral sign, the equal sign here. Sorry about that. So let's move on here. In our next step, we can get the square root of 9, and we're only maintaining what we have here. So this is equivalent to the integral of, so here this will be only the term containing 1 plus tan square theta. The square root of 9 is 3. We can place it right away here, and inside here we have 1 plus tan square theta, and we have here cube. So this cube is also for all these numbers here. Now term is 3 secant square theta d theta. Oops, we forgot also the theta here. Now let's go on and open up this by distributing our power 3 to this term containing the root and also here. So when you cube 3, you get 27. So let's push on, and we have the integral of, let's again organize our work. This 3 is ready to cancel one of these 3. Sorry, this one was not 3 but 27 because we have already cubed it out here. Or if we need to first maintain that stage, we can have this one here to power 3. So when we cancel this 3 with one of the 3, we shall be left with only 2 here, and then 3 exponent 2 is 9. So let's make it in our next stage. And we also know that the inside part here is the same as secant theta. So let's go on and also replace that denominator before crossing it out. Now here we have 1, and down here we now have 9 secant theta because it is on the square root, so we still have our cube here. Now we multiply this one with the remaining secant square theta d theta. Now let's open up that bracket by cubing secant theta in our next step here, and we still have our 9 lingering around here. So we have secant cube theta times our secant square theta d theta. So also the numerator is still 1, and also we can cancel out this one with 2 of this one, and we left with only 1. So in our next step, we can rewrite this one as the integral of 1 over, let's bring this 9 outside, so we have 1 over 9, and the only thing left here is secant theta because 2 of them cancel, so with respect to theta. And also from trigonometry that 1 over secant theta is the same as cos, so we have just simplified our integral to 1 over 9 integral of cos theta with respect to theta, and this is now basic integral, which is easy to handle. So the integral of cos theta is sine theta plus our constant of integration. So we have only one step to go where we need to change this variable from theta back to x. So let us get back. How do we get this theta back to x? You know, somewhere we made substitution of tan, and that tan was this one here, where we say tan theta is given by this. So we can go on and draw a right angle triangle to get us a relationship that would also make us know sine theta. So from this triangle here, tan theta that was given by x plus 3, let us be sure by first looking at it, is x plus 1 over 3. So let's erase this part out. Now we have x plus 1 over 3. So the numerator is opposite, and our opposite here happens to be this side, x plus 1. And then adjacent is 3. So hypotenuse will be the square of this side. 3 square is 9, and the square of the opposite here from Pythagoras theorem, where we have that, and we don't have to forget our square root sign here. And now go ahead and write a relationship of sine. So we know sine of any angle theta is given by opposite over hypotenuse. So the opposite is this parameter here, that is x plus 1 over, we can have the denominator down here as square root of 9 plus x plus 1 square. So we can go on and substitute to our final answer here, and we have 9 multiplies this figure here. Maybe I can put it in bracket like that. So we have our x plus 1 divided by, push a little bit up here, and the root of and let's provide enough space. So we have and the root of 9 plus x plus 1 square. So we can close up this and add our constant of integration. Now, since we have 1 here, we can just match this one up, and finally we'll have something that looks like here. And if you leave at this stage, it's just okay. 1 times this numerator will remain the same, so you can just have x plus 1 over so let's have the square root sign here, and we attach our 9 around here. So 9 into also the 9 inside there plus x plus 1, and we square it plus the constant of integration. So this is complete answer, which has been written in standard form. If you have got some value, please go ahead and subscribe to the channel. I'll be uploading videos of this kind almost every day. See you in the next one. Peace out.